Reservoirs have varying degrees of aerial permeability anisotropy. In naturally fractured formations, ratios of maximum to minimum horizontal permeability can be 50 to 1 or more. But even in presumably homogeneous sands or channels, these ratios may be 3 to 1 or higher. This is not an issue in vertical wells, because the controlling permeability of radial flow is simply the square root of the maximum permeability times the minimum permeability. But a horizontal well's performance is based largely on whether it is normal to the direction of maximum horizontal permeability. If its trajectory matches this optimal direction, its performance, expressed here in terms of incremental net present value ratio, will likewise be optimal. Conversely, a well that deviates from this optimal direction will significantly underperform similar wells drilled in less anisotropic formations. The greater the anisotropy, the larger the impact of misorientation. Clearly, if we know the permeability anisotropy and direction, our best course of action is to drill a properly oriented single horizontal well. But if these quantities are unknown, we can reduce the risk of misorientation by drilling a second branch at right angles to the first. This is one of the oldest rationales for using multilateral wells. The incremental benefits of multilateral wells are generally based on increased well-to-reservoir exposure. As pseudo-steady-state flow conditions take over and wells feel the effects of their outer drainage boundaries, the productivity indices of all configurations converge. In other words, the productivity index of a multilateral star configuration will eventually converge to that of a single horizontal well. But in lower permeability formations, this convergence may take a relatively long time to occur, thereby allowing multilaterals to attain recoveries that are significantly higher than those from single horizontal wells. Of course, multilaterals must be justified not just on the basis of incremental production, but rather on incremental net present value. As drilling and completion costs are reduced, these configurations are likely to be very desirable accelerators of production, and thus a form of stimulation.